Thank you for joining us at Mountain Films. I'm Liz Rosenbaum with Fountain Valley Clean Water Coalition, and we live in Fountain, Colorado, about 2 hours south of Denver. And I'm here with my friend Arlene Blum. She's an amazing scientist and mountaineer, and she is just such a great advocate for a healthy environment. And I got to actually meet you in person in Boston, which was really quite lovely. It was the second national PFAS conference. So I was really looking forward to seeing you in person again, but I will take this as a great second option. So thank you for coming, Arlene.
Well, I'm so happy to be talking to you. I kind of wish we were all in Telluride, but next year in Telluride. And I'm here to tell you about adventures, both adventures in the mountains, adventures in high places, and also adventures in making the world a safer and healthier place. And I think right now this is very appropriate to be thinking about these things because we're in the middle of a pandemic and it's very obvious and things are happening very fast. But at the same time, there are other pandemics that are more slow moving, like climate change, the plastic pollution in our oceans. And what I work on is harmful chemicals in everyday products that contribute to our cancer, our neurological impairments of our kids, infertility, and a host of health problems. And I think all these things can be solved. The slow-moving pandemics. It takes having a vision, getting a team together, and moving slowly, step by step up the mountain. So we're going to talk a little bit about mountain climbing as a metaphor for solving other big challenges. Our current pandemic and the slow-moving pandemics of climate change, plastic pollution, and what I'll talk about mostly is toxics. So with that, I will start my story. Okay, let's see how to get this to go away so I can see the top of the slide. Okay. So I'm going to be talking about, as I said, the summits of mountains, but also healthier products, healthier people, and a healthier planet, which is something we all want. So my story started back in my freshman chemistry lab at Reed College. My freshman chemistry professor was this very enthusiastic young woman. She was 23. She had a PhD from MIT. She thought chemistry was the coolest subject on the planet. There were 4 girls in my freshman chemistry class. We all got doctorates in chemistry. The other important part was my lab partner, a handsome young man from Portland, Oregon. He was a mountain climber, and we studied chemistry till late one starry night. And he said, "Do you want to go climb Mount Hood?" And he was very handsome, so I said, sure. I was from Chicago. I'd never done anything very physical in my life. He put a big pack on my back, and he later said I started up the hill from Timberline Lodge on Mount Hood, gasping so loudly. He didn't think I'd make it out of the parking lot, but he was very handsome, so I continued. We got high on the mountain. It was the most beautiful place I'd ever been. I fell in love with him and with mountain climbing. And chemistry and mountain climbing have been 2 of my passions ever since. In 1970, just when I finished my qualifying exams at Berkeley, I heard about an expedition to Denali, the highest mountain in North America. And I applied to go, and I was told that women could go as far as base camp to help with the cooking, but that women were not strong enough to climb high mountains like Denali. Well, I had actually climbed higher than Denali with my friends from Reed College and when we climbed in Peru. And I thought, I wonder if a team of all women could climb Denali. And we did. So this was the first all-women's climb of Denali. And that really inspired me to realize that we can do harder things than we believe possible if we really want to. So I kept alternating between mountain climbing and molecules until an easy peak in India called Trisol, but it was 23,000 feet high. And one of the climbers was at that time America's leading young rock climber, Bruce Carson. And we were climbed to the summit. And when I reached the summit, I realized that Bruce was there. He had fallen through a cornice to his death. And no one knew the cornice was on the summit. He had unroped. We were just heartbroken. And he was an early environmentalist. He pioneered climbing the steep walls in Yosemite without pitons. He actually led people like Yvonne Chouinard and Royal Robbins up the first grade sixes ever done in the valley. And so in his memory, I decided I wanted to do something for the environment. And I had on my PhD committee at Berkeley, a guy named Bruce Ames, who had a rapid screening test to see if chemicals were likely to cause cancer. So I went to him and I said, is there something I can do for the environment? I'm so depressed, my friend died climbing. And he said, well, could you look at the flame retardant in kids' pajamas? And that seemed a little strange, but in those days, up to 10% of the weight of the fabric in the pajamas that all children were wearing was a flame retardant called brominated tris. And so he said, see if it gets into the children. So I found a little girl whose mom had gotten her pajamas in Europe, and they didn't have tris. And we put the little girl in the tris pajamas, collected her urine, and the first morning there was tris in the little girl's urine. She wore the pajamas for 4 days. Every day the level of tris went down, and she stopped wearing them, it went down. So this was a worry. Tris was getting into children from their pajamas. Chemicals that we put in our mouths, like foods, drugs, pesticides, are regulated. You may argue how well, but they are regulated, and other chemicals really aren't. So we decided to do a screening test for tris, and we discovered that it was a mutagen. That means it changed DNA, and it was likely to cause cancer. So this was huge, and we thought, we have to write a paper and tell the parents of America so kids can stop wearing tris pajamas. And then I got an invitation to Mount Everest. And at that point, in 1976, Everest had only been climbed once by Americans in 1963. So we were the second team to have an opportunity to climb Mount Everest. And in those days, you had the whole mountain to yourself, one expedition on Mount Everest. So I had this terrible decision. Did I stay home and write the paper about the tris pajamas, or did I go climb Mount Everest? And so I did both. While I was climbing in these beautiful places in the Khumbu icefall, putting ladders across crevasses, climbing up steep ice faces, going through the Khum, every night I would get to my tent and I'd write my paper. My high point, about 24,000 feet on Everest, I had a flag. On the left, the little petri dish doesn't have much tris, not many mutations or colonies. On the right, lots of tris. And so I finished my paper. It was sent by mail runner to Kathmandu, and it was published in Science. We reached the summit of Everest in October 1976, the bicentennial. We were the second group of Americans ever to climb Everest. I actually had an altitude record for American women at that point. And then just a few months later, our paper was published as a lead article in Science. And the subtitle of this paper is quite unusual. If any of you read scientific papers, you know they always end with the same recommendation. They always recommend more study. And here we had just done a couple experiments, and we said the main flame retardant in children's pajamas is a mutagen and should not be used. And that was really a strong statement, and that's what we do at our institute. We're scientists who do science in the public interest. We write papers in good journals, and we make strong statements to change things so we can all be healthier. So the paper came out in January 1977. April 1977, tris-treated pajamas were banned, which is just what you would want to happen in 3 months. And brominated tris was out, but what was the replacement? Chlorinated tris, a chemical that was almost the same, had the same structure, function, and toxicity. We studied chlorinated tris. It also changed DNA. It was also removed from kids' pajamas. But what we didn't know is that it continued to be used in other products like furniture. Like if any of you have a couch that you bought between about 2004 and 2012, the foam in your couch is likely about 5% by weight tris. But we didn't know that. At that point, all the world's high mountains, mountains of 8,000 meters, had been climbed by men, but no woman had climbed that high. And so I applied for a permit for Annapurna 1 on our way back from Everest. our team. We're all still friends. We were going to be having a reunion in April. We've postponed it till September, but we all still get together. And I wrote a book about the trip, Annapurna Woman's Place. We did reach the summit. We were the first Americans and the first women to climb Annapurna 1. And after that, I wrote a second book, Breaking Trail, asking how I had gone from pretty overprotected childhood where I wasn't allowed to do things like ride horses or go to the beach because it was too dangerous, how I went from that to leading an expedition to such a dangerous mountain. And when I finished Breaking Trail, I actually spent 20 years writing Breaking Trail. It was like a big personal therapy project. I'd had a very tough childhood, trying to understand how the difficulties in my childhood led to the strength of my adulthood, or my being able to lead these expeditions. I ended by saying, I don't know what's going to come in the future, but I hope I can use my science to break trail to a better world. And I actually hadn't been doing science for like 25 years. I had been walking across the Himalayas, climbing mountains all over the world, and then raising my daughter. And so I really didn't know what was going to happen next. And I just have to say, I started doing the work I'm now doing, we're talking about, and every day feels like I'm on Annapurna. Because with a great team of people, and we see our summit, it's a healthier, better world for all of us. So I founded the Green Science Policy Institute. We write scientific papers, do educational meetings, we have retreats, and our goal is changing policy and changing what people purchase so we do not have toxic chemicals in everyday products. So what is the problem? It turns out that we are not protected from harmful chemicals. There are about 80,000 chemicals under production, and back in the 70s, a law was passed regulating chemicals, but 62,000 chemicals were grandfathered. Those are things like tris and asbestos, for example, which kills 10,000 people a year, cannot be regulated by the EPA. It's regulated by lawsuits, but anyone who wins an asbestos lawsuit dies. So that's not the way you want to regulate chemicals. Another big problem is what we call the regrettable substitute. You remember brominated tris was removed from kids' pajamas. It was replaced by chlorinated tris. For the chemists in the group, you can see on the left a couple of rings with like 10 bromines around them, decabromo diphenyl ether. It's a flame retardant. The plastic in your television, if it's an old television, 15 or 20% of the weight of the plastic will be that decabromo diphenyl ether. It's highly persistent. It bioaccumulates up the food chain. It's toxic. And when you turn on your TV, it comes out and goes into dust and ends up in you. And after years of advocacy and research, it was phased out of use. And then the replacement is on the right, decabromo diphenyl ethane, similar in structure, function, and toxicity. And so that's what tends to happen. So this was a problem, tens of thousands of chemicals, the fact you spend years regulating a chemical and it's replaced with something similar. So what's the solution? If you think about tens of thousands of chemicals, it might feel a little bit hopeless, but if you divide them into families of similar chemicals, it's a way of dealing with them. And so at one of our first retreats, we came up with the idea that there were 6 classes or families that contain most of the harmful chemicals in everyday products. And we have a series of 4-minute videos. We won't show you one today, but you can go online to sixclasses.org. And in 4 minutes, you can watch a video and learn about one of the classes. There's an introduction, so in 7 times 4, 28 minutes, you can learn a lot about what are the harmful chemicals in everyday products, where do you find them, what's the health harm, what you can do to avoid them. And we always put in a success story, so it's not too much of a worry that there are these unfortunate chemicals. Now, sometimes you do maybe need these chemicals, but the question we ask is this chemical necessary? If you say to a mom, you can have a wonderful stain repellent carpet, but the chemical is going to be in your child's body for decades and it's harmful, she might not think she needs a white shag carpet she can drop chocolate ice cream and Coca-Cola on. Is it worth it? And then if she really wants that white carpet, then is there a safer alternative? So I'm going to talk a little bit about flame retardants. Back in the 70s, there were a lot of fires. People put flame retardants in many products. The flame retardants, for example, in a couch, in the foam, they're called semi-volatile. They come out of the couch, they drop into dust. If children who crawl in the dust and then put their hands in their mouths can have a higher, 4 to 10 times higher level than their parents. Adults usually get some dust on their hands, eat a sandwich. Cats who groom themselves, their levels can be up to 100 times higher than humans. The flame retardant that was used almost exclusively in foam from the 80s through about 2004, when it was banned in 140 countries. It's been shown, almost everyone has this in their body because it was in all our furniture coming out into dust. Anyway, it makes it harder for women to get pregnant. It's been associated with cancer, and it changes hormones during pregnancy. So children, if their mother's higher levels, have various neurological impairments. The average American kid has lost 3 to 4 IQ points because of the flame retardants in their furniture. So this was a huge problem. And also, believe it or not, there's no fire safety benefit. Fires start in fabric, not in foam, and putting all the flame retardants in the foam does not stop fires. It makes almost no difference. And so when I heard that, I remembered back in the 70s how we got flame retardants out of kids' pajamas in about 4 months. And I wrote an op-ed in the New York Times, somebody did some legislation, and we thought we would just solve this in a few months. So it turns out we had 4 bills over about 6 years, and everybody, all the furniture manufacturers, the firefighters, parents, scientists, everybody supported moving these toxic flame retardants out of our furniture, which contribute to cancer and so many health problems. And you actually can have increased fire safety by stopping the fire in the fabric rather than putting all these flame retardants in the furniture. So it seemed like a winning argument, but we never won. Every time we had a bill, there was a huge lobbying effort from Californians for fire safety. They actually spent a documented $23 million in Sacramento preventing California from moving to increased fire safety without flame retardants. And the California law was being followed across all of the US and Canada. So all the couches, foam in children's products, most foam was like 5% by weight, these toxic flame retardants that had no fire safety benefit. But the flame retardant producers, the 3 companies who made the flame retardants, would do anything to keep the flame retardants in. So finally, we invited some Pulitzer Prize winning journalists to one of the hearings where everybody was opposed to the flame retardants, but the legislators who had been given a lot of money voted for the flame retardant industry. And so they wrote a real expose. You can see the headline: "A deceptive campaign by industry brought toxic flame retardants into our homes and into our bodies, and the chemicals don't even work as promised." And if you Google "playing with fire," it's scandalous stories, and they won every journalism prize. And I started hiking with our governor, Jerry Brown, senior advisor. And in those days, anyone who went hiking with me got an earful about flame retardants. And so I educated his advisor. The governor learned, with the help of this article, the flame retardant industry stopped lobbying so hard, and our California law was changed. So if you go to buy a couch now, there'll be a label on it, and it will be checked, contains no added flame retardants. So every home, pretty much in America and Canada, new couches since 2013 most would not have any flame retardants. And this is my glamour slide. People thought this was one of the best things Jerry Brown would had done. And so I actually got inducted into the California Hall of Fame, and there was Robert Redford and Joan Baez and a whole lot of my heroes. So it just shows that being a scientist, you can get as much acclaim as you could imagine. So now I'm going to tell you about my favorite class of chemicals, which is the one we're going to be discussing after my talk. And they're my favorites because they're the worst. These are the stain and water repellent chemicals called PFAS, per and polyfluoroalkyl substances. You don't have to say that. It's kind of confusing. But they're a class of 4,000 chemicals. And because the carbon-fluorine bond is so strong, it never breaks, never for a million years. So these chemicals, which are used to make the Gore-Tex that makes your jackets waterproof, they're used in wax, they're used to make Teflon, they're toxic, and they never go away. These chemicals also have good properties like oil and water repellent. So I don't know if any of you have seen the wonderful film Dark Waters with Mark Ruffalo and Anne Hathaway. And it's the story of my good friend, attorney Rob Ballott, who we work with. He goes with us to the Hill to talk to people about these chemicals. And he discovered this massive contamination with these chemicals. And anyway, it's an incredible chemical thriller. I really recommend it if you haven't seen it. And he won a large lawsuit, and he used all the money to do health studies to learn about the harm from these chemicals. And what he found is that they were linked to cancer, high cholesterol, obesity, and a whole host of health problems, and they're in pretty much all of us. So we, and a big problem, the harm was known back in the 60s of these chemicals called C8, where you have 8 carbons surrounded by fluorine that are highly persistent, bioaccumulative, and toxic. They were phased out in 2015. It only took 50 years. And the replacement were chemicals called C6, 6 carbons surrounded by fluorines that share similar properties, mostly that they never break down ever. They build up and they're toxic, not the sort of chemicals you'd want to have a lot of, for example, in your drinking water. Unfortunately, the chemical industry marketed C6 as a perfectly safe solution, and they have all these nice ads, and the manufacturers kind of fell for it. So everybody went from C8 to C6, even though C6 appears to be just as problematic. And for those of you who are chemists, you'll like the argument that C6, which is 6 carbon chain, is safe because it cannot break down to an 8 carbon chain, right? Makes no sense. But in any case, that's, again, the regrettable substitute. So we got together and we wrote a scientific statement signed by 230 scientists on the harm of the whole class of chemicals, all 4,000 of them. We did a lot of publicity, got articles, chemicals in your popcorn. If you get interested by these chemicals, read the Teflon toxin series in The Intercept. But the thing that changed everything was a New York Times cover story, The Lawyer Who Became DuPont's Worst Nightmare. And indeed, that was the story of the movie Dark Waters. And when that came out, people became outraged, and they demanded that the EPA set a level, what is safe and what is not safe, because large amounts of these chemicals were in drinking water all over the country. And one of the places is Colorado Springs, which we're going to be talking about more soon. But as scientists, we had a group of scientists from all over the world. For the last 8 years, we've been meeting once a month to come up with ideas for scientific research on these chemicals. And we said, let's trace back to where does the harm come from? We knew that the EPA had measured drinking water around the country, found areas with high levels, and we traced back and discovered that the source of a lot of it was places where chemicals and products were produced. Military fire training areas, they use these chemicals as firefighting foam, and they do a lot of practices where they just would spill thousands of gallons into local rivers, lakes, ground. So airports, wastewater treatment plants process it. They're not the source, but it does accumulate. So we wrote a paper tracing back from contaminated drinking water to the sources. And just at that time, because of all the publicity from the Rob Bilott article in the New York Times, the EPA set a level of what was safe and what wasn't safe. And once we had that level, we calculated in our paper that 6 million Americans' drinking water was above that level, including a lot here in Colorado. And actually, this paper, for those of you scientists, has had about 35,000 downloads, which is amazing for a scientific paper because it had really important information. So the cost of getting these chemicals out of drinking water is really high. In North Carolina, there was a plant that made the chemicals and polluted this whole Cape Fear River area. To build a carbon filtration plant, that's one way to take them out of water, is $46 million and then $3 million to operate it each year. A treatment called reverse osmosis works better, and they estimated $99 million to build the plant, and again, $2.9 million to operate. It's extremely expensive. And this just gives you clean drinking water. It doesn't help with all the contamination of land and air and soil and the wildlife. So here in Colorado Springs, nearby, Peterson Air Force Base, firefighting foam contaminated the water supply of 70,000 residents. And the sum of those chemicals in drinking water is 20 times the EPA health advisory level. And the residents have levels of one of these chemicals 10 times higher than the national average. There are studies now being made on the health effects near Peterson Air Force Base, and they have been given clean drinking water. So PFAS are problematic, difficult to clean up. We think prevention is preferable, and now I'm going to give you some optimistic stories about how these problems can be solved. And one way is through community advocacy. We're going to be meeting after this talk. I'll be having a conversation with Liz Rosenbaum, who in 2016 founded the Fountain Valley Clean Water Coalition. Their goal is to educate, empower the community, and change the future to prevent further contamination. And they host meetings, push for remediation, and advocate for the prevention of further pollution. So we're going to be talking about PFAS here in Colorado. Liz is on the left, and in the center is Rob Bilott, the attorney whose story is told in Dark Waters. As scientists, we did some work. We knew that these chemicals were used in wrappers that fast food was put in. They make paper, oil, and stain resistant. So pizza boxes, fast food wrappers. So we did a study of 400 products, and we discovered about 40% contained these chemicals. We did a lot of publicity. The word got to the US Senate, and senators wrote letters, like to Burger King, and that's Molly, my cat, who wants to join the conversation. Burger King and other companies who sell fast food, and the fast food industry, based on this, we've heard, have pretty much stopped using these chemicals in fast food wrappers, which is a really good thing. Carpeting is another story. Stain repellent carpets are one of the major sources of exposure for children. And again, we worked with the carpet industry. We educated them. They had switched from C8 to C6. We said, no, C6 is still a problem. They came to understand it. And the carpet industry decided they were going to stop using this whole class of chemicals in all new carpets. And they did, because the deadline was January 1st, 2020. And Home Depot and Lowe's are now advertising that they're selling all their rugs and carpets do not contain any of these PFAS chemicals. And that's because the companies decided to phase them out. A lot of clothing manufacturers have decided. We worked with IKEA, and when they learned about the harm, they phased all PFAS out of all their textile materials worldwide. There are good alternatives for water repellency, but not such good for oil and grease repellency. They said, we didn't find a good alternative for tablecloths, so IKEA stopped selling tablecloths because they weren't going to sell anything with PFAS. Crate and Barrel also, they learned what IKEA had done, and they decided to do the same thing. Some of these other companies were picketed by Greenpeace, but they've all phased out all PFAS. Really great thing, the National Defense Authorization Act, that's the military budget, and it requires bipartisan cooperation, and that's what we have had. There's contaminated communities throughout the country, and legislators from both sides of the aisle, when they have contaminated communities, they are concerned. And so with good bipartisan cooperation, the military defense budget for 2020 is requiring the military to phase all PFAS out of firefighting foam by 2022. And that has been really a major source of contamination. So this is great. There's going to be water sampling throughout the country. Anyway, a lot of good things are happening with a lot of bipartisan support in the House and Senate. So we're moving away from PFAS in rugs and food packaging, furnishings. Outdoor gear is moving slowly. Firefighting foam also. So if you become obsessed with PFAS like I am, we have a website called PFAS Central with the latest news, policy, meetings, everything about PFAS. And we have a page called PFAS Free Products, where you can look up different products that contain no PFAS and make choices away from this whole class of chemicals. So again, if you want to learn more about this, go to sixclasses.org. And you can see in half an hour all about the 6 or 7 classes, 6 classes plus an intro, and have healthier products, which leads to healthier people and a healthier planet. We send out monthly newsletters. If you want to hear from me once a month, when you go to sixclasses.org, it gives you a chance to sign up. And I actually send quarterly newsletters, which are more about the outdoors and mountaineering and a little bit about toxics. So send me an email. You can Google me, or it's Arlene@greensciencepolicy.org. You can find me and send me an email if you'd like to hear from me quarterly. So I think by limiting the use of these classes of chemicals, we can have a healthier world. And I'm optimistic. I think right now the world has slowed down, and people are thinking more about what they touch, what they breathe, what they eat. And I think people can be more conscious of moving away from toxics, moving away from plastics. We're all flying less and driving less, reducing climate change gases. So I think we have our pandemic, but we also have the slow-moving pandemics of climate change, plastic pollution, and toxics, which is what we work on. And I feel that we're working together at this pause. When the pause ends, we can all climb together, I hope, to the summit of a healthier world. So thank you so much. And Liz and I will be talking shortly about what's going on in Colorado with PFAS.
So Arlene, thank you for your thoughtful presentation that we all just watched. And I have a few questions that maybe you could expand on. What are some of the biggest problems around PFAS? Are there more dangerous PFAS than others? What one do we want to sort of fear the most or be on the lookout for?
Well, as I said, there's 4,000 kinds of PFAS, and they're all forever chemicals that never break down. And unfortunately, all the ones that have been well studied turn out to be harmful. So when it was determined that there was contaminated drinking water in your communities from 2 military bases, the military did indeed give you good drinking water, but at the same time, they switched from one PFAS, the old long chain PFAS, to the new PFAS, the short chain. And I actually had the opportunity to speak to the people in the Pentagon who are the decision makers on this. And I said, this is a big mistake because the short chain goes through the filters so it can go into the drinking water, and it also is a forever chemical. It's not really much of an improvement, but they unfortunately spent a lot of money switching from the old PFAS to the new PFAS and then burning the old PFAS. And the places where they burn it tends to be near low-income communities. And when you burn PFAS, unfortunately, it's such a strong molecule. It's the strongest bonds in the periodic table. When you burn it, it turns out it doesn't break down very much, and it just spreads the PFAS. So that is a big problem, that once you make forever chemicals, they're there forever. And switching from one kind to another doesn't help. And it's time to switch away from all PFAS. And a bit of really good news is Congress, bipartisan Congress, House and Senate, told the military that in 2 years they have to stop using all PFAS. And they have to, because Congress told them. And I always think it's a bit of good news that around PFAS, our government in Washington, D.C. is working in a very sensible bipartisan fashion. Do you find that surprising?
Yes.
The bad news is there's PFAS contamination all over the country. And the more we look, the more we find anywhere where there's been an airport, a military base, a production facility, manufacturing. Unfortunately, people find contaminated drinking water. And then you have the elected representatives from both sides of the aisle really concerned. And so it's bad that there's that much contamination, but it's good that elected officials are concerned and they are doing things about it. And you know, what we believe is cleaning up is really hard and expensive. Like, you can't really, once you've contaminated with PFAS, you can give people clean drinking water, but you can't really clean it up. It's so expensive and so difficult. And so prevention is always cheaper and better, and that we really need to stop putting PFAS in our products unless it's absolutely essential, and it really isn't essential. So I think one thing communities can do is really focus on not buying products with PFAS. So we think it's important for people to learn where PFAS is likely to be, and then to try to buy products that are PFAS free. So for outdoor people, jackets are important, rain jackets, and companies are starting to make them without PFAS, and they can look on our PFAS free page and reward the companies that aren't using the chemical by buying PFAS free products, which is healthier for them and healthier for the environment, because it's really the manufacturing of these products that leads to a lot of drinking water contamination. But also was legislation passed that the U.S. Geological Survey is going to be looking all over the country for more communities that have PFAS in their water, and that will raise the political will, but also raise the expense of trying to do something about this contamination.
Have you heard of other states collecting information for what's on people's shelves as an inventory?
I think Washington State is. Washington State was the first, several years ago, they banned the use of firefighting foam containing any PFAS, and they also, Washington State was the first to ban the use of any food contact materials containing PFAS, because, you know, fast food wrappers, because PFAS keeps oil and grease from leaking through paper. So fast food wrappers used to contain PFAS. And it's funny, even where I live in Berkeley, like these organic restaurants, we tested some of their packaging and it contained PFAS, and they were not pleased. But Washington State has led the way, and there's efforts, you know, right now for something national about not allowing PFAS in food packaging. Denmark has done that. Denmark's the first country. Last August, Denmark said no PFAS in any kind of paperboard food packaging. So that's really a good example. And I think other countries, other states will follow. And so slowly, I think we're going to stop the use of this. And it's important, it needs to be as fast as possible, because these are the forever chemicals. Once they're in the world, they're there forever. So it's really good to hear about groups like yours who are working for legislation. I mean, that's so important to help the different fire districts to switch away from PFAS.
I'm so happy to hear that you have a list of outdoor gear that we can purchase and phase out. So with phasing out, what do we do with our old garments?
Well,
do we just hang on to it for a little bit longer until we can safely dispose it?
Well, I'd say the manufacturing is the biggest problem. So when people say, what should I do with my Teflon pan or my Gore-Tex jacket? I'm like, it probably won't harm your health, but don't buy another one. So I wouldn't dispose of them,
Got
but I
it.
wouldn't buy more. When you buy new things, buy things that are fluorine free. And that will cut
Got
down the manufacturing, cut down the contaminated drinking water. And we really hope the world will move away from this whole class of harmful chemicals. And I think communities like yours can take a real leadership role for all of us. So I really appreciate your good work.
Yes. Thank you. And I appreciate everything that you've done with teaching us how to be more successful as consumers. My last question for you is, what is the proudest moment you have had in fighting against PFAS? Is there a moment where you felt, aha, I am accomplishing great things, someone is listening to me? Tell me about that.
Well, that's a nice question. Thank you. Well, I think we had a meeting with the carpet industry who had switched from the old long chain to the new short chain, and they really thought they'd done the right thing. And they came to our meeting not really wanting a bunch of scientists from Berkeley to tell them differently. But we had a lot of scientists, a lot of business people, big purchasers, big companies there, very credible people, all of whom realized that the carpet industry really shouldn't be moving from the long chain to the short chain. They should just stop using PFAS. And at the end of the day, one day, the leaders from the major carpet companies said, we believe you. We're going to stop using PFAS and we're going to take it out of America's carpets. And it's hard to believe, but they did. And so that was really extraordinary to me. And this year we had a call with them and they said, we are so glad we learned how harmful those chemicals were and we found better substitutes. So carpets still are stain repellent without PFAS. And I'm like, wow, I cannot believe that happened so fast. So that was really extraordinary and surprising to me that that happened. And I have to
Thank
commend
you
the
for
carpet.
sharing that story.
I just should say I should
Yeah,
really
we should
commend the
share
carpet.
more wins like that. Yeah, we should share more wins like that and get more people on board. So thank you so much, Arlene. It is just amazing to always talk to you.
So thank you. And we're all on the same expedition. The summit is a healthier world, and working together with your group and a lot of people in the audience and overcoming obstacles, avalanches, storms, step by step, I hope we'll head towards the summit of a healthier world. So thank you.
I agree. Thank you.